We're going to start with section 4.5. I'm going to call this part 1. We're going to graph some more functions today, but today we're going to graph cosecant and secant. Okay, so remember that sine of theta and cosecant of theta are reciprocal functions. Okay, cosecant is equivalent to the reciprocal of sine. And I think I've been using the term inverse, but that's not really what I should be saying. I should be saying that these are reciprocal functions. Okay, cosecant equals 1 over sine, and sine equals 1 over cosecant. Okay, cosine and secant are also reciprocal functions. Secant is equal to 1 over cosine, and that's going to be important today. Okay, so we're going to start by looking at the graph of cosecant of x, or cosecant of theta, keeping in mind that this is equivalent to 1 over the sine of x. All right, and so to graph cosecant, we're actually going to start by graphing our sine function. Okay, and really when we graph this function, we're graphing off the unit circle. Okay, so when we start at the origin and we start at 0, right, if I look at my unit circle, right, at 0 degrees, the sine is 0, right, and so I put that point there. At pi over 2 degrees, the sine is positive 1. At pi, or I shouldn't say pi over 2 degrees, at pi over 2 radians, at pi radians, the sine is 0. Okay, at 3 pi over 2 radians, the sine is negative 1. And at 2 pi radians, the sine is 0. Okay, so that's really how we're getting these points. Okay, we're pulling those right off that unit circle. Okay, so if I were to graph 2 periods of the sine function, it would look like this. All right, so from sine, because cosecant is the reciprocal of sine, now I'm going to graph cosecant. Okay, the first thing that I want to point out is that cosecant is the invert, or is the reciprocal of sine. Okay, so if sine is 0, right, at 2 pi if the sine is 0. Okay, the reciprocal of 0 is 1 over 0, which is undefined. You can't divide by 0. So everywhere the sine function equals 0, cosecant is going to be undefined. Okay, so I'm going to have an asymptote there. Okay, I'm going to have an asymptote there. All right. Okay, so let's look now at, let's come over here to pi over 2. Okay, at pi over 2, sine is 1, and the reciprocal of 1 is 1. So that means at pi over 2, sine and cosecant are the same, right? They're both 1. Okay, but let's say we have this point here where the y value is 1/2. Okay, and this would actually be pi over 6, but at pi over 6, sine is 1/2. That means at pi over 6, cosecant is 2, right? The reciprocal of 1/2 is 2. Same thing over here, and this would be 5 pi over 6. Okay, when at 5 pi over 6, sine is 1/2, which means cosecant is 2. Okay, so this graph is going to come up. It's not going to cross those asymptotes. It's going to go right up to those asymptotes. Okay, same thing here. At 3 pi over 2, sine is -1. The reciprocal of -1 is -1. Okay, so that point stays the same. And that goes like that. Over here, this is the same. The sine of -pi over 2 is -1. The reciprocal of -1 is -1. Okay, so this goes like this. This comes up here. That goes like that. Okay, so the graph of cosecant, right, we've got all these asymptotes right here, and then it looks like the blue, this kind of parabolas, right? That is the graph of cosecant. Okay, we are going to graph secant the same way, okay, using the fact that secant is the inverse of cosine. Okay, so the period of cosine is -2 pi, or I'm sorry, is 2 pi, so I'm going to graph from -2 pi to +2 pi. Okay, when we start, if we start at 0, right, again, and I'm just looking at the unit circle, at 0 degrees, the cosine is 1. Okay, that's why we're starting up at that amplitude. Okay, at pi over 2, cosine is 0. At pi, cosine is -1. Okay, at 3 pi over 2, the cosine is 0. And at 2 pi, the cosine is +1. Okay, so there's one period, right, of that cosine graph. And here's my second period. It's going to come up like this. All right, same principle here. At -3 pi over 2, cosine is 0. The reciprocal of 0 is 1 divided by 0. I can't divide by 0, so that's undefined. Okay, so same thing as that sine function. Everywhere cosine equals 0, secant is undefined. I'm going to have an asymptote there. Okay. With my cosine function, right, at 0, the cosine is 1. The reciprocal of 1 is 1, so secant is the same. Okay, and then the same thing as a sine function. If this is 1/2 right here, the reciprocal of 1/2 is 2. Okay, so I have a point that goes up this way. It's going to go right up to that asymptote. Okay, same thing here. Okay, if this is 1/2, this would be 2, right? And so it's going to look like this. Okay, so the graph of secant is going to look like that. Okay, so that is the graph of cosecant. This is the graph of secant.